So assignment the question 1, assignment 7 question 1 has got to do with this figure, and let's read it out. So figure 1 shows a mechanical press for punching out identity cardboards. Crank AB, this is a crank AB, which is a link 2. Crank AB is pivoted to the frame link 1. Okay, so that's the ground link 1. And the coupler BC, which is the coupler BC link 3, which is this, at A and B. So, and the coupler link BC, which is link 3 at A and B. Okay, so what are they saying? Crank AB is pivoted to the frame link 1 and the coupler BC at A and B respectively. That doesn't make sense. Pivot joint C connects coupler link CB. Pivot joint C connect coupler link CB, which is link 4. CD or CB, CD, which is link 4, and CE, which is link 5, and rocker link CD. CD, what is CD? CD, which is link 4. So how do you get link 4 at CB and link 4 at CD again? Alright, a lot of mistakes in there. Link CE drives slider E. So link CE, which is this one, drives slider E. Slider E, okay, which is link 6, which is constrained to move vertically through the frame. The actual length of crank link 2 is 150 mm. Calculate the mobility of the linkage. So before we start, we need to calculate the mobility of the linkage. Maybe I should do it somewhere here. So mobility is given by M is equal to 3 into bracket N minus 1 minus 2J1 minus J2. So our number of links N, so before that, N is equal to 6, which is ground link 1, 2, 3, 4, 5, 6. Our J1 is equal to, J1 is 1 degree of freedom joint. So we have 1, 2, 3, 4, 5, 6, and 7. Here we have 2 joints there. So let's count again. 1, 2, 3, 4, 5, 6, and 7. So 7. Our J2 is equal to 0. So M will be equal to 3 into bracket 6 minus 1 minus 2 times 7 minus 0. And that will be 15 minus 14. And that is 1. So our mobility is 1. Okay. The next is determine the number of instance centers. So number of instance centers is given by number of IC is given by N into bracket N minus 1 all over 2. We have 6 links. So 6 into bracket 6 minus 1 over 2, giving you 3 times 5, giving you 15. Okay. At the instance, okay, so the next is at the instance shown, locate all the instance centers of the press. Okay, so instance centers, do you remember what it is? So any point where links meet, right? Okay, so some are obvious, some are not. So here I have link 2 meeting link 1. So that is instance center 1, 2, instance center 2, 3, instance center 3, 4, 3, 5, and then 4, 5. They all meet at the same point C. And then here will be instance center 1, 4. And then this point will be instance center 5, 6. And then 1, 6 will be on the slider link. Okay, so there are some that I've located. You are going to use the Kennedy method. Maybe, okay, so I'm going to draw our circular track. Then we label around it with the number of links. So we have link 1, maybe 2 here, 3 here, 4 here, 5 here, and 6 here. Alright, so from here we join those that are known or obvious. So we have instance center 1, 2. So I join 1 to 2. I have instance center 2, 3. So I join 2 to 3. I have instance center 3, 4. 3 to 4. That same point I have 3 to 5. That same point I have 4 to 5. The next is instance center 5, 6. 5 to 6. The next is instance center 1, 6. So 1 to 6. And then instance center 1, 4. So 1 to 4. Okay, so we've been able to connect all the obvious instance centers. So the next we're going to look at the ones that are not obvious and locate them. Alright, so you start from 1. 1 is connected to 2. So you connect 1 to 3 and look for it. So we use short dashes because we don't know that instance center yet. So any triangle formed with that 1, 3, any instance center that forms a triangle with the instance center 1, 3 will create a line that will contain all the 3 points. What I mean is instance center 1, 2, instance center 2, 3, and instance center 1, 3 will be on the same line because those centers forms one triangle. In the same way, instance center 1, 4, instance center 4, 3, and instance center 1, 3 will also be on the same line. This concept is the Kennedy's theorem. I know you don't need that. So now I have a triangle on my right, 1, 2, 2, 3, and 1, 3. I don't know 1, 3, but I know 1, 2, 2, 3 will form a line that will contain 1, 3. So where is 1, 2? Okay, here is 1, 1, 2. And then here is 2, 3. So I go to 1, 2, 2, 3. And then I just draw a line. Right, I don't know where the 1, 3 is, so I just draw any random line. Then the next triangle that is created with the 1, 3 is 1, 4 and what 3, 4. So 1, 4 is here, 3, 4 is here. Oh, okay, so they are meeting up here. All right, so I joined, and the center they meet is going to be what 1, 3. All right, so now that I've found it, I make it a solid line so that I won't be confused. The next is also 1 is connected to 3 now, 1 is connected to 4. The next is what 1 to 5. 1 to 5. Okay, so 1 to 5, we have triangle 1, 6, 5, 6, and then triangle 1, 3, 3, 5. Okay, so 1, 6, 5, 6. So 1, 6, 5, 6. You go to 5, 6, and then you draw a line perpendicular to the sliding surface through 5, 6. All right. Okay, so this is 1, 6, 5, 6. A line perpendicular to the sliding surface passing through 5, 6. So the next triangle 1, 3, 5, 3, right? 1, 3, 3, 5. So this is 1, 3, this is 3, 5, and then they meet the line here. So the point here becomes our instance center 1, 5. All right, so now we make it a solid line. We are done with that. So now 1 connect to all the other links. So you move to 2. So you connect to 3. Oh, 2 is not connected to 4. So short dashes. Okay, so the triangles, I have triangle with instance center 2, 3, 3, 4. So 2, 3 is here, 3, 4 is here. So I'll come here to my straight edge, and then I'll draw a line. Okay, the next triangle I have 1, 2, 1, 4. 1, 2. So this is 1, 4. This is 1, 2. So 1, 2, 1, 4 here. Okay, they met here. So this will be 2, 4. Then take line now. So the next is 2, 5. 2, 5. I have triangle 2, 4, 5, 4. 2, 4. 2, 4 is here. 5, 4 is here. So this line. And then triangle 1, 2, 1, 5. So 1, 2, 1, 2 is here. 1, 5 is here. So 1 2 1 5 1 2 1 5. Okay. So this is 2 3 3 5 or 2 4 4 5. So I just have to extend this now. Okay, so they met here. So that point is going to be 2,5. Then you join with what? Second line. Okay, so now I move to 2 6. So 2 6 short dashes. So we have triangle 1 6 1 2, and then 2 5 2 6 2 5 5 6. Okay, so which one first? 1 2 1 2 1 6. So we go to 1 2. I think this one we could use several triangles. Okay, it's just those two. 1 2 1 6. So we go to 1 2. Draw a line perpendicular to this surface through 1 2. Okay, so this is 1 2 1 6, this line, and the next is 2 5 5 4 2 5 5 4. This 2 5 5 4 is here, so they meet here, and that will be 2 6 2,6. Okay, let me be sure. So 2 5. No. That is not true. Okay, so this is 1 6 1 2 1 6 1 2, which is this line. The next line is 2 5 5 6. So 2 5 is here, and 5 6 is here, right? So 2 5 5 6. So 2 5 here, and then 5 6 here. Okay, so it meets the line 1 2 1 6 here. So this is going to be 2 6. All right, you've made it this far and you haven't subscribed, can you do so? Maybe an evil person. Okay, so now you connected 2 to every link. So you move to 3. 3 is connected to 4. 3 is connected to 5. So you connect 3 to 6 with short dashes and look for it. So any triangles from with 3 6. So 3 6, I have 3 5 5 6. 3 5. Where is 3 5? 3 5. 3 5 is here, right? This center C. 3 5 5 6. So this line 3 5 5 6. Okay, the next is 2 6 2 3 2 6 2 3 2 6 2 3. Okay, 2 3 2 2 6 2 3, and then 3 5 5 6. Yeah, so that is going to be 3 6 6. So this is 2 6 2 3. 2 6 2 3 will give us 3 6, and then 3 5 5 6 3 5 5 6. This. Okay, so now 3 is connected to 6 as well. Connect them. So 3 is connected to everything now. So you move to 4. 4 is connected to 5. 4 is connected to 6. So short dashes. Alright, so we have 5 4 5 6. 5 4 5 6. So 5 4 is here, 5, 6 is here, so this line. Okay, and the next triangle we have 3, 6, 3, 4. 3, 6, 3, 4. Okay, on the same line, so we need to choose another triangle. 3, 6, 3, 4, and then 5, 6, 5, 4 are on the same line. So we need to choose another triangle. Okay, we have 2, 6, 2, 4. Right? 2, 6, 2, 4. 2, 6, 2, 6 is here, and then 2, 4 is here. Okay, so 2, 6, 2, 4 is here. Okay, so this line meets this line here, and then that is what? 4,6. Good. There is a point. 1, 4. Let me see. 1, 4, 1, 6. There's a slight error, because if you use 1, 4, 1, 6, you will come here and draw a line here. There's a slight error. Alright, so none of them should work. Okay, so the next one is the next one. I mean, if you use 1, 6, so you can use 1, 6, 1, 4. So for that, you have to go to 1, 4, draw a perpendicular line through that, right? So that would have met this guy down here. You see, so there's a little difference from using the 1, 6, 1, 4, but I think it's from little errors in the diagram. But I wouldn't change anything. Whichever one you use, that is fine. All right. So the next one. Okay. So now that you find 5, 4, 6, 4, you join them. Then the next one is 5. 5 is joined to 6, joined to. So everything is connected to everything. So you can count them, right? So I mean, it's a lot. From here you can see 1 joined to 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and then 3, 4, 5, 6, 1, 4. Minus everything is joined to everything. So we are done, and this represents our instant centers. Of the diagram. We've identified all of them. So the question said that if at the instant shown, the crank link 2 is rotating at 10 rads per second clockwise, determine the angular velocity of link 4. So we're going to look for angular velocity of link 4, the speed of the slider, and indicate the direction. And then at the instant shown, slider 6 is moving downward at this speed. Determine the rotating speed of the crank. Okay, so do I even have a lotus? Okay, so let me try and work here. So at the instant shown, the link 2, which is the crank, is rotating with 10 rad per second. So we have omega 2. What you're looking for is link 4, right? So omega 4 on omega 2 is equal to plus or minus 1,2 to 2,4 all over 1,4 to 2,4. So this plus or minus, you check whether 2,4 is between 1,2 and 1,4, or it is outside 1,2 and 1,4. So when we come here, let's look for 1,2. So 1,2 is here, 2,4 is here, and then 1,4 is here. So you can see 1,4, 2,4 is outside 1,4 and not 1,2. So we are going to use the plus. Okay, so we are going to measure 1,2 to 2,4. 1,2 to 2,4. What do we have? Hold on. I have 3.6. No, 3.55. Yeah. So I have 3.55 here. It's more like 3.5. So 3.5 here, and then 1,4 to 2,4. 1,4 to 2,4. 1,4 to 2,4. That is 12.6. Right. So I have 12.6 here. this is equal to omega 4 is what I'm looking for. Now omega 2 is clockwise, so that's negative 10. So omega 4 will be equal to 3.5 over 12.6 times what? Negative 10. Okay, so I use the calculator. 3.5 out of 12.6 times negative 10. I mean, there could be some errors in the diagram, right? So there's always going to be plus or minus, so don't worry. So omega 4 is going to be what? Minus 2.78 rad per second. So the minus indicates that it is the same direction as the 10, which is what? Clockwise, right? So omega 4, they said we should find and use arrow. So the arrow will be this, right? Okay, so our next calculation is to find the speed of link 6. In the question said that the link 5, right, link CE, which is link 5, drives link 6. So what it means is that we are going to look for the velocity at the tip E here, and that velocity will be the velocity of the link 6. So we know omega 2. We are going to use that to find angular velocity 5, and then we will use that to find the velocity at 0.56. So omega 5 on omega 2 will be equal to plus or minus again 1,2 to 2,5, 1,5 to 2,5. So we need to look for 1,5. 1,5 is here. Where is 1,2? 1,2 is here. Okay, 2,5 is here. So 2,5 is outside 1,2 and 2,5. So we are going to use what? The plus. So omega 2 is negative 10, clockwise direction. So yeah. So 1,2 to 2,5, what are we getting? 1,2 to 2,5 is giving us 7.7 centimeters. So 7.7 here, and then 1,5 to this rich no 1,5 to 2,5. So from here that's like 14.8. So omega 5 times negative 10. So omega 5 will be 7.7 out of 14.8 times 10. So that is negative 5.202. So this is omega 5. Alright, so we know that the length 5 here will be rotating in the clockwise direction, just as the length 2, negative 5. Okay, so we need to find the velocity of 0.56. all right? So now we know that velocity is equal to omega r. I get it. So the r is the distance from like the center of length 5, which is 1,5, right? The ground point of length 5, 1,5 to 1,5 to the 5,6 will be our r. Okay, so now the r is equal to, so on the paper, on the sheet here, r is equal, oh come on boy, r is equal to 1.55. Yeah, 1.55. So more like 1.6. So I'm going to make 1.6. R is equal to 1.6 centimeters. But in the question, they said that a measurement, where is it? Link 2 is 150 mm. So what it means is This link 2 is 1.9. Right, so 1.9 on this sheet is equal to 150 mm in real life or the actual diagram. So that 1.6 we've measured should be what? So let's put x here. So that measurement is this time that. So that will be 150 times 1.6 out of 1.9. And that will be 126. So x will be 126.32, which is 0.12632 meters. So our velocity, and you measure to the left, right? So it goes to negative. So negative 5.202 times negative 0.1263. So that would be negative 0.1263 times negative 5.202. So that will give us 0.657 all right, 0.657. So yes, this guy here is going to go upwards because it's positive direction. Okay, yes, so this is going this direction, this one has to rotate like this, one will go up. All right, so now we have this done. So the velocity of the slider block 6 is going to be the same as the velocity at the 0.56. The next is that at the instant shown, slider 6 is moving downward at speed this, determine the rotating speed of cranks. Okay, good. So let me turn this back. So now they are giving you the velocity of line 6, and you know that the velocity there is equal to the angular velocity times the radius. I guess it. Now the velocity given there says going down, and you know we are giving downwards direction as negative. So negative 5 meters per second is equal to the angular velocity that we don't know times the r, and the r here is what? Negative, right? Where is it? The r is negative 0.2. One calculated here. Negative 0.1263. Negative 0.1263. All right, so omega will be equal to 5 divided by 0.1263. So we have 39.58 rad per second. All right, so now we know the angular velocity of length 5. So then is they gave you the sliding velocity of length 6, right? And then the sliding velocity of length 6 is the same as the linear velocity at the 0.56, which happens to be on the length 5. So if I know the sliding velocity at that point and I know the radius from there to the center of rotation, then I can use the radius and then that velocity at the 0.56 to get the angular velocity of length 5. Now that I know the angular velocity of length 5, the question asks that, where is it? The question asks that I should determine the rotating speed of crank AB, and you should tell whether it's clockwise or anti-clockwise. So we are going to use the same relationship we used here, right? The same relationship here. So omega 5 on omega 2 was equal to 7.7 over 14.8. 7.7 over 14.8. So now that we're looking for omega 2 will be equal to 14.8 over 7.7 times what? Omega 5, which is 39.58. So this will be equal to 14.8 out of 7.7 times 39.58. So we have 76.08 rad per second, and it's going to be what? Anti-clockwise because it is positive. So that is that for assignment 1. If the video was helpful, I would say that like and share for your friends to also benefit. And once again, if you haven't subscribed, hit on the subscribe button. Thank you, and see you in the next question.